In these notes, we are going to be talking all about slope. Every little piece about it, we're going to be graphing, we're going to be finding slope. So here, the definition for slope is a non-vertical line through 2 points. See, we have here x1, y1, and then x2, y2. That just shows that we have 2 separate points here, the first point and the second point. So then we'll be going ahead and using the slope formula. So this is a formula that should be memorized at this point. So our slope is m equals y2 minus y1 over x2 minus x1. Okay. So then we have here some examples. So I went ahead and already worked out those examples for you here. So it says find the slope of the line through these 2 points. So through these 2 points, I went ahead and labeled x1, y1, x2, y2. Then I went ahead and I know I have our slope formula. So I went ahead and I plugged in the y values up top here and the x values on the bottom. 9 minus 4 is 5. 7 minus negative 3 is positive 10. So we get our slope to be 1/2. So m equals 1/2. And notice how I wrote out my answer. I made sure to say the m equals 1/2. The next one is another example. So here we are given this point x1, y1, here x2, y2. Now notice I just chose the first point is to be x1, y1. It does not matter. You could have flipped it around and that could be the x2, y2. We go ahead, we plug that in. Here are the y's and here are the x's. When we go ahead and subtract, we will go ahead and get the slope to be -6/5. So slope. What does slope even mean? So slope, we talk about it as the rise over run. Okay, we talk about it as the rate of change, so the change in y over the change in x. Okay, we also talk about slope when we are looking at the slope-intercept form, right? So y equals mx plus b, right? And so that m is going to be the slope. Okay, so there are a couple different types of slopes. There are positive slopes, negative slopes, zero slopes, and undefined slopes. So positive slope, you see here our line is increasing. We're going from left to right. We are increasing. We are going up. Okay, so that's positive. Here in this next one, this is a negative slope. It is going in a downward direction, right? Downward, so it's going to be negative. Okay. The next one here, this is our horizontal line. Horizontal, think horizon. The horizontal line is a zero slope. Think about this one as if you were walking across this line, you could walk across it. You would not be increasing, you would not be decreasing, you're just going to be walking straight across. So here the slope would be 0. Now, however, if we're going to go ahead and talk about the undefined slope, this is when our slope, if we were to try to walk up this here, we would not be able to, right? The only person that can walk up that is spider. We're talking about parallel slopes. If they are parallel here, they will be the exact same slope. So as you see these 2 lines here, they are parallel, so our slopes will be the same. These next ones, this is just saying that if you have them here, if they are horizontal or vertical, whatever they are, they would still be the same. So these are vertical, the slopes would be the same, and in this case, they are undefined. Right, since they are vertical, they would still be undefined. Okay, the next one talks about perpendicular. Okay, so remember perpendicular, this is the symbol for perpendicular. So non-vertical lines, which just means here we have 2 lines that are going in different directions. One's and it does not have to be horizontal, vertical. They can be on angles. So we have 2 lines here intersecting, line 1 and line 2. They are perpendicular to each other. Since they are perpendicular, their slopes are opposite reciprocals. Okay, so opposite reciprocals. As you can see here, the notation for perpendicular slope is m, and then there's a little t down at the bottom. So the reciprocal of our slope will be the opposite. So let's say our slope here for line 1 is 2. The perpendicular slope for line 2 would be -1/2. Okay, so opposite, reciprocal. Okay, so one of them will be positive, one will be negative, one will be a fraction, and one will not. Okay, so in this example here, this next one, we have a horizontal line and a vertical line. Now, so we can have slopes like this. However, we have to remember the slope of line 4 is undefined. Okay, and the slope of line, here's our line that's intersecting there. And then this one would have a slope of 0. Okay, next we have a couple examples. So over here at this point, as I'm going through these questions, you can speed up or pause, whatever you need to based on what problems we're doing. So this one just says find the slope of lines parallel through this line. Okay, so we need to find a parallel slope, which means the slope will be the same. So from line 1 and line 2, they will have the same slope. So let me just put m equals m. Okay, so they're going to have the same slope, so I'm going to go ahead. I went and wrote here, this is my first coordinate, this is my second coordinate, here is our y's, here are the x's. When I go ahead and solve, we'll get -10 over +8, which equals -2. So our parallel slope is -2. Next question, it says find the slope of lines perpendicular. So here it's talking about lines perpendicular, which means, right, we have that upside down t. We are going to find the original slope, and then we are going to find our perpendicular slope. Okay, because we know our perpendicular slope is the opposite reciprocal. Alrighty, so over here to find our slope, we have m equal 7 minus -5 over 8 minus 4. So over here we will get to have a +12 over 4, and our slope will be 3. Now, this is the original slope. Now we need the perpendicular slope. So here we will take the opposite reciprocal, so we'll have -1/3. So our perpendicular slope, here is our perpendicular slope. All right, so a couple more questions we have. This is probably one of the trickiest questions and where I find the most mistakes. So here it says find the value of k, so that we have the coordinate 3, k. We have the coordinate 5, -4, and we have this coordinate here. And we want them collinear, which means on the same line. So we need to find what the slope is, because no matter what, as long as we find what the slope is, we can find what this point is. So we are eventually going to get to the point where we have m equals, and let's say I use these 2 points here, m equals -4 minus k over 5 minus 3, right? And we can get the slope. But now, a couple things that we're missing. We're missing the slope and we're missing a k. But we sure can find a slope if we go ahead and use these 2 points here to get their slope and then plug it in. So I'm going to go ahead and find the first step here would be m equals, I'm going to use these 2 points here. We have 7 minus -4 over -2 minus 5. Okay, so over here we will get a lovely -11 over 7 as our slope. So m equals -11 over 7. Okay, so from there we're going to go ahead and plug in that slope into this guy here. So we will have in our next step -11 over 7 equals -4 minus k over 5 minus 3. Now, there's a fraction. Please be careful. If you are not good with fractions, use your calculator to help you. But at this point, we should be pretty comfortable multiplying with fractions. Here, this actually becomes a 2, so I'm going to go ahead and multiply both sides by 2 to get rid of that there. We will then have here negative 22 over 7 equals negative 4 minus k. All right, so then from here we're going to add 4 to the other side. When we add 4 to the other side, it'll give us a positive 6 over 7 equals negative k. We'll divide by the negative 1, and we will get k to equal negative 6 over 7. All right, so now we have found the value of k. That makes those 3 points collinear. All right, so we're actually going to skip this question for right now, just so my video is not too long, and go to these ones. So these next questions are asking you to test the collinearity. What a word. Okay, so here you just have to make sure that we're going to be testing all these points and finding their slope to see if they are collinear, which means you just find the slope of all of them. So we're going to be finding the slope between these two here. We're going to find the slope between these two, and then we're going to have to find the slope between these two. So at this point, I'm going to pause the video, or you can pause the video to check to first find all 3 of those slopes, and if they are all the same, then we know they're collinear. Alrighty, so I went ahead and found the slopes for the first one. So over here, if you take a look, we found the slope of the first 2 points that I have underlined in blue, m equals 2. I found the 2 slopes of the 2 points that I have lined with pink, and the 2 slopes that are lined with green. Now, as you can see, they're the same slope, so these points are collinear. In the next one, I went ahead and I found the slope of the first one, right? The first 2 that I found. We got m equals 6 over 5. The next one, though, I found m equals 9 over 8. So I'm not even going to go ahead and do the third one because these first 2 points aren't even collinear, so that answers the question. All you need is 1 to prove that it's not true. Okay, next, graphing lines, our favorite thing. So these first 2, I'm going to go ahead and graph them. So graphing the lines through these 2 points, which means I'm literally just going to go ahead and plot those points. So we have negative 7, 1, 2, 3, 4, 5, 6, 7, up 5, 1, 2, 3, 4, 5. That is the first point. The next point is over 6, down 8. So 1, 2, 3, 4, 5, 6, down 8. 1, 2, 3, 4, 5, 6, 7, 8. Alrighty, so here's our lovely line. On my computer, I have this awesome ruler, which you also have, that you could totally use to make your lines nice and beautifully straight. Okay, here is our first line. So that is through those 2 points. The next one, it gave us the slope and a point. So I'm going to graph this point. Here we have 1, 2, 3, 4, 5, up 2. And the slope is 5 over 3. So I'm going to go rise 5, 1, 2, 3, 4, 5 over 3. And I know looking at this 1, 2, 3, 4, 5 over 3 that this slope is positive, so it's going to be a line increasing to the left. So 1, 2, 3, 4, 5, 1, 2, 3. When you are graphing, you want to make sure your lines look just as beautiful as my lines. I need to have more than 2 points. So as you see here, I have enough points to go across my whole graph. As you see here, I also have arrows at the ends of my lines. You also see that my lines are perfectly straight, so I expect that your lines will also be perfectly straight. Okay, I will not be accepting things if you go like this, and this is your line that you give me. So that line that I just drawn here, I will not accept anything like that. They need to be nice lines. Okay, and then next here is another example. That one's just with a negative slope. Over here, I'm going to do this one really quickly. So these ones are your horizontals. So I'm going to pause the video to have what they look like. As you see here, the first line I have in blue is a 0 slope. The one with the 0 slope, you know that it's going to be a horizontal line where you can walk across it. You can also look to see at these points here, and you don't really need anything else other than the point and knowing that's a 0 slope. Okay, the next one here, I did this in green. So this here has this no slope. That means we know it's going to be a vertical line. It's going to go through that point vertically, and that is it. Thank you.